Hey YouTube, welcome back. Today we have this problem. It's called invert binary tree. Given the root of a binary tree, invert the tree and return its root. So basically we have this tree. It's 4. Basically we have it like that. So we have 4, 2, 7, 1, 2, 3, and we have it like that. And basically we want to invert it, so it will be the left, right, and the right, left. But also look at something, it's fully inverted. So basically if you looked at the subtrees like 7, it's this also invert, and if you looked at this subtree, this also inverts. So basically we're inverting the full tree. So let me just copy this one and go here and just try to paste it. And basically, can we, I guess, can I have some? Yeah, okay. Okay, so basically what we can do, I guess, let me just delete some things, and also I will delete, this is from the previous problem. So, okay, that's nice. Okay, so what we do that, we will create a recursion function. Okay, first this recursion function will check if we have a root. Do we have a root? Okay, so run this function on the right and run this function on the left. Okay, and okay, so when you go here again, this will be the new root. Do we have a root? Yes. Okay, so run this function on the right and run this function on the left, and we have this here. Okay, do we have root? Yes. Okay, so run this function on the right and run this function on the left, but basically there is no root here and there is no root here, so we're returning null both sides. And so we will go back to this function that was waiting, and it was saying that the root, this is root, root dot the root dot left, this, sorry, the root dot left, this is the root right now. Root dot left will equals root dot right, but both of them is equal null, so it doesn't do anything. So we go back here, we go here back. Okay, it doesn't say anything. So basically we go back here and we say do root dot left equals root dot right, and root dot right equals root dot left. And we go back basically to 7. We did to 7, we go back to 4, and we just loop these two things, and also we will loop these two things. We will not loop, we will just swap, basically swap these things, and the solution will be, I guess, about like 5-6 lines of code. It's a recursion, so what we should do with each recursion, we should get the base case, and I would say if root equal, because we don't want the function to run infinitely. Return null. I would say var right will equals inverted binary tree. This one again we call, and I will say root dot right, and I'll say var left equals the inverted binary tree root dot left. And after we run the recursion function on the right and left and we swap them, we swap the same thing. I will say that root dot left equals right, and root dot right equals left, and return root, and voila. Okay, so let's see how this works basically. So let's just start with can we delete all of that, for example, because I guess I don't need all of that. Okay, so I will say that first of all, root will equals 4, because we're starting with the first one. Okay, and basically we are right now in 4. So I'm saying right now, if root equals null, no, actually root doesn't equal null. Okay, so run this function on root dot right and root dot left. So basically the root dot right is 7. So basically I'm running this function again and I pass to it root.right. So basically it will equal 7 right now. So root right now equals 7. So I'm saying that, okay, does root equals null? Actually, no. Okay, so basically we had the root.4. When root.4 is waiting for root.7 and root that equals 2 to finish, okay? However, root that we are right now in root.7, I'm saying is root equals null. No, actually root doesn't equal null. So okay, run this function on root.right and root.left again. So I'm passing root.right will be 9. So will be root right now it equals 9, okay? And I'm saying, okay, does root equals null? No, actually root equals 9. So okay, run this function on right on left. However, right on left on 9 there is null. So basically when you loop this, when you call this recursion function again, it will return null. These two functions of the 9 nodes. And root.left, which will be 9.left will equals 9.right. It's null. Doesn't have anything basically. And basically, however, the thing that will happen that we will have the root.7 is waiting to root.9 to finish, and after root.9 finish, which is the right part, we will go with the left part, which will do the same thing. And after that, what we're going to do is that we will do this step that root.left equals right and root.right equals left. So basically we're swapping these two characters, so basically two numbers. So basically 9 and 6 and 6 and 9, we're swapping them. And also when we finish that, we will swap the full subtree. And basically that's it for today's video, and I hope my description was quite clear, and see you in future problems.